Okay, Trig kids, this is section 12.3. This is the last section that we're going to do for matrix operations or matrices in general. Today and tomorrow we're going to do this video, and then we'll start our final review packet on Wednesday. So these are going to be the type of problems that you're going to see probably the most on the ACT. They'll just write your matrices kind of looking like this. So kind of keeping in mind the same concept as what we had in the last couple sections. What you'll a lot of times see on the ACT is you'll see things that look like this, where you're adding two matrices together. So you might have like 1, -4, 5, -9, 2, 6, -3, 4. I don't know, something like that, where you're adding together, right? What this really means is 1x minus 4y, and you're adding that to 2x plus 6y, something like that, right? And the bottom one would say like 5x minus 9y and -3x plus 4y. So when you're adding these together, like you're basically adding this top equation to this top equation, but you're doing like two of them at one shot, right? So you're adding these two equations together and you're adding these two equations together to get an altogether new equation really fast. So 1 and 2 will give me 3, -4 and 6 will give me 2, 5 and -3 will give me 2, and -9 and 4 is -5. So I can figure out that if I were to add those two together, I would have 3x plus 2y. And if I would add those, or add these two bottom ones together, I would get 2x minus 5y. Okay, so it's just a really fast and easy way of adding things with x's and y's together without having to rewrite the x's and y's every single time. Okay. So matrix operations, we have, like over here, they're talking about dimensions of matrices. So this one is a 3x3 matrix, 3 rows. They always go rows and then columns. So 3 rows, 3 columns. This one has 4 rows, 1, 2, 3, 4, and 1 column. So it's a 4x1 matrix, which we haven't seen yet before. But yeah, that's kind of an interesting one. Now, these are not augmented matrices, so we don't have an equal sign. So basically in this section, we're just doing expressions, right? Like x minus 4y, there's no equal sign in there. We're just adding that to 2x plus 6y. There's no equal sign in that until, we put the equal sign here where we're adding them together. But we're not adding equations together. This isn't an augmented matrix where we have that dotted line, okay? So what they do a lot of times here is for a matrix, they denote like this number here is A11. This means row 1, column 1. This is row 2, column 1, row 3, column 1. So this guy right here would be row 3, column 2, right? A32 means row 3, column 2. You always list the row first, okay? And so on and so forth. So they would kind of denote those as that way, okay? When you're doing matrix addition and subtraction, okay, notice how I did that up here. I was adding those together. This was a 2x2 and this was a 2x2, and it became another 2x2, okay? Think about if I would ask you to try to add these two together. Like, how would you do that, right? Which pieces would you add to which pieces, right? This one is a 4x1 matrix. This is a 3x3 matrix. Well, what happens is with addition and subtraction, they have to be exactly the same size matrices. So matrices that have the same dimensions may be added or subtracted by adding or subtracting the corresponding entries. So this top left one will be added to the top left one, etc., right? Okay. For matrices that have different dimensions, addition and subtraction are not defined. So if I were to ask you to add A and B together, if I say, what is A plus B? You would say, nope, can't do it because they're not the same size, right? So that kind of makes it nice. But example 1, they want us to first find A plus B. So I'm going to do A plus B over here. Then they want us to do A minus B over here. Okay. A is a 3x3. B is also a 3x3, 3 rows, 3 columns. So I can add those together and I can subtract those. Okay. And what's going to end up is another 3x3 matrix and another 3x3 matrix. Okay. So in the first one, we're going to add these together. And if you want to write it out where, you're writing out this guy plus this guy like I have up here, you can totally do that. But I think maybe we're advanced enough that we can just add the cells together. So I would say 3 plus 5 will give me 8 in the first cell. Let's go across the top. So 2 plus a -6 will give me negative 4. Negative 5 plus 2 will give me negative 3. Okay, now this seems really easy, but it's really easy to make a mistake. So be careful when you're adding these together, especially if you have negatives. 6 plus 4 is 10. 1 plus 5 is 6. 7 plus a negative 4 is 3. Okay, last row. Negative 2 plus 1 is negative 1. 0 plus a negative 1 is still going to be negative 1. And 5 plus 0 is 5. Okay, I'd be surprised if I didn't make a mistake on that one, but I don't think I did. Okay, A minus B. So taking all the A's and you're subtracting these guys over here. So this would be 3 minus 5, negative 2. 2 minus a negative 6, so 2 plus 6. That would give me 8. Negative 5 minus 2 is negative 7. That's what he would look like. Okay. Next row, 6 minus 4 is going to be 2. 1 minus 5 is negative 4. 7 minus a negative 4 is 11. Or 7 plus 4 is 11. Okay, last row. Negative 2 minus 1 is negative 3. 0 minus a negative 1 is 1. And 5 minus 0 is still 5. Okay, so just really fast, easy ways. This would be like an x variable, a y variable, a z variable. And I really have 3 expressions that I'm adding or subtracting, and I'm doing those all at the same time. So it just kind of makes it fast and easy. Okay. The next thing that they will talk about is scalar multiplication. So like, let's say I have 2x minus 7y plus 3z, and I want to take that whole thing and I want to multiply him by 4. Well, what I would do is I would just take and multiply through everything by 4. Well, that's what we're doing here with 3 different equations, 3 rows, okay? And I'm doing 3 variables, so x, y, and z, but I'm multiplying all of them by 3. So this would be like a 3 out in front here, and I'm doing that 3 to 3 equations, 3 different variables, and it's really fast, okay? So they want us to find 3a, so this would look like 3 times all of that. I just take every single number in here and multiply him by 3. Okay, so 3 times 3 will give me 9, 3 times 2 is 6, 3 times negative 5 is negative 15, 3 times 6 is 18. Ooh, I'm going through this kind of fast. 3, 21, negative 6, 0, 15. That's what he would look like. So 3a as a new matrix will look like this guy. Okay. Now, in addition to that, they might do some things like, I don't know, they might say, what is 3a minus b? Okay. So you would figure out what 3a is, and then you would subtract the b values from it. Not terribly hard. So you have scalar multiplication here, and you have some subtraction going on, but it's kind of the same general concept. Okay, so on to the next page. I'm going to do maybe 1 or 2 of these, and then we will stop and I'll finish because multiplication is a little bit trickier. Okay, matrix multiplication. All right, here's what can happen. When you are multiplying matrices, you can multiply matrices that are different sizes. Okay. But what you need to make sure and do is, like, let's say you have a matrix that is a 2 by 3 matrix. Okay, I have a matrix, my first matrix that I'm starting out with is a 2 by 3. Okay, and let's say I want to multiply him by something else, a different matrix. Let's say that he is a 3 by 1 matrix. Okay, so I have a 2 by 3 matrix. Here's an example of this: 2 rows, 3 columns. So I'll have 1, 4, negative 3, 5, negative 1, 9. Okay, that's a 2 by 3 matrix. A 3 by 1 will look like this: negative 2, 7, 5. That's 3 rows, 1 column. Okay, I can only multiply matrices together if these 2 dimensions are the same. Okay, so if I'm taking a 2 by 3 times a 3 by 1, these 2 pieces have to be exactly the same number. Okay, otherwise this does not work. Now, if I would switch these 2 around and say I want to take that 3 by 1 matrix times that 2 by 3 matrix, right? Even if I would just switch these in a different order, right? Which most of the time you can do, like if we're just doing numbers, like 2 times 3 should be the same thing as 3 times 2. Well, it doesn't work that way for matrix operations. If I try to flip those 2 around and multiply them in a different order, now these 2 inside dimensions are not the same number, and I cannot do it this way. I would have to multiply them in this order, okay? And so we'll kind of look and see how that multiplication happens, okay? But those 2 inside numbers when you're doing your dimensions, you need to be exactly the same, okay? So here's how multiplication works. All right, they first want us to find multiplying A, B together. I gave us kind of a big, huge area here because they want us to do 4 pieces. So AB, BA, AC, and CA. Okay, so I'm giving us a lot of room down here. We're just going to do AB all the way across here, and I'll kind of show you how he looks, okay? So the first thing that I'm going to do is I'm going to rewrite A and B together. So 3, 1, 2, negative 1, 0, 4. I'm just going to rewrite him. And this is 2, 0, 1, negative 3, 5, 8. Okay, so that's what he's going to look like. So A times B, okay? Now let's look at the dimensions for A. Let's write them up here. A is a 2-row, 3-column. So he is a 2 by 3. B has 3 rows and 2 columns. Okay, so 2 times 3. So I have for AB, I have a 2 by 3 that I'm trying to multiply by a 3 by 2. Okay, first of all, can we do this? Can we even multiply AB together, or does it have no solutions? Well, these two middle numbers tell me yes. Since those two dimensions in the middle are the same, then I can multiply those two together. Okay. Now, what will happen is in my very, very final answer, imagine, so if those two numbers are the same, imagine as though you would cross those guys out, and the dimensions of your new matrix would be 2 by 2. Okay, so this final answer is going to look really weird. He's going to be a 2 by 2 matrix. Okay, so all we have to do is figure out what those 4 numbers are for our 2 by 2 matrix, and then we are done multiplying. Okay, so what we do here, I should have made this a little bigger, but that's okay. What we do here is we're going to take this row times this column. Okay, so this is going to look kind of funny. We take this row times this column. So this 3 I multiply by the 2, the 1 I multiply by the 0, and the 2 I multiply by the 1. Okay, so 3 times 2, 1 times 0, 2 times 1. And what I do is at the end, I add those numbers together. Okay, so in this cell right here, in this cell, I take 3 times 2 plus 1 times 0 plus 2 times 1. Okay, I'm taking this row times this column. Okay, because when we think about back to this piece right here, A32 meant row 3, column 2, right? I take a row times a column to get A32. So this guy is the first row. His name would be R11, not R, AB11, AB11, because that's what we're doing, we're multiplying. So 11 meaning the first row of A times the first row of B, okay? And we add those all together, and that gives me this cell. So 3 times 2 is 6. 1 times 0 is 0. 2 times 1 is 2. So I take 6 plus 0 plus 2, and this guy is going to be 8 right here. Okay. All right. Now let's move over to this next one. Okay. This is the first row and second column. Okay. So what I'm going to do is I'm going to take my first row times my second column. Okay. So first row, second column, and I do the same thing together. Okay. I take 3 times negative 3. Plus 1 times 5 plus 2 times 8. Okay, so 3 times negative 3 is negative 9, plus 5 times 1 is 5, plus 2 times 8 is 16. Oh my goodness, negative 9 plus 5 is negative 4, plus 16 is 12, I think. So that's what he would be, okay? Now this guy right here, this cell is the first or second row, first column, right? That's what he is in this matrix right here. He is in the second row, he is in the first column. So what I'm going to do is I'm going to take the second row times the first column here. Okay, so second row times first column, and then I'm going to add them together to get this piece. Okay, so I start with negative 1 times 2. That's second row, first column, first piece. Okay, then I have 0 times 0. Okay, plus 4 times 1. Okay, so negative 1 times 2 is negative 2, plus 0, plus 4 times 1 is 4. So negative 2 plus 0 plus 4 is going to be 2 in this spot. Okay, The last one, this guy in this matrix, is in the second row, second column. Right? So I take my second row here times my second column here. Okay, so these two are going to be multiplied together. So I take -1 times -3. Okay, I take 0 times 5, and I take 4 times 8. All right, so -1 times 3 is going to be +3, plus 0 plus 4 times 8 is 32. Okay, so 3 plus 32, this guy is going to be 35. Okay, so my entire answer is this 2 by 2 matrix. 8, 12, 2, 35 is what he will look like. Okay, all right, now, blah, 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 blah. Let's go ahead and stop there. That's an introduction into matrix multiplication. We'll do the last 3, and we'll do example 4 in the next video, because that kind of takes a little bit of time. Okay.